Section 6.2 dealt with substitution if you have to integrate that way. Substitution is a nice way to integrate, but it's not always possible. So we have to have other methods for other functions. So this one here is called integration by parts. Okay? Works quite a bit. But always try substitution first because it's easier. Okay? This formula, you notice, or should notice, has a u and then a dv, which is kind of weird. Okay? The one thing you may want to write off to the side before we even start, when you do integration by parts, you have to replace everything. It's not like substitution where you could leave powers in there or leave sign in there or leave e in there. That's not going to happen with integration by parts. So they're saying basically you're going to represent some of the stuff with a u and some of the stuff with a dv. Right? And everything will get replaced when you rewrite it. They're saying once you figure out what u and dv are, the solution is take whatever u happens to be and take it times whatever v happens to be. And then you're going to subtract the integral of whatever v times du is. So a lot of people remember uv minus v du. Okay, they just remember the integral in there. Okay? So it'd be really helpful if we got here and it was something we could actually integrate. As you can see, this is a process that could go on for a very long time if we keep getting something in that spot that we can't integrate. Those we save, as you can see, it says day 1. Those longer ones we save for later days. We just get the setup going first. One of the suggestions I always use is this dv that we've got over here. I'm hoping you notice that there's a dv here, and then all of a sudden there's a v over here. How are we going to get from dv to v? What are we going to have to do? dv to v. Well, if we had v to dv, what would we have to do? Take what? Derivative. So if I'm at dv and I need to get to v, I need to take an antiderivative. So the best idea is to look in the problem and make dv something that you can actually integrate rather easily. Okay? And doesn't make it worse. So let's just try it. We're going to have to make something u. This is, oh, I went with mu again. We're going to try it. It's kind of like, so something's going to be u, something's going to be dv. This is how I set it up. You don't have to set it up this way, but this is normally what I do. Now remember, everything in there has to go somewhere. Okay. Now really this one has an x and an e to the x, right? And really either one of those I could integrate, right? But I'm going to tell you we probably don't want to make x dv. Okay. We're probably going to go with e to the x. Is that pretty easy to take the integral of e to the x? It's just what? E to the x. Well, that's not so bad. So let's try it that way. Now, is it possible we could try some of these, e to the x dx? And over here is x. Is it possible we could try this and it doesn't work? Unfortunately, yes. Okay. It may be very possible that we're going to have to try various options, sounds like substitution sometimes. Now let's see what else this formula, I made it very colorful up here. What else is this formula going to ask me for? Right now I know what u is, so that one right there, do I know what that is? Yep, check. Do I know what v is yet? Nope. What I normally do is I write that down here, and really what I have to do, if you want me to write it off to the side, and I'll do it for you here, what we're really going to do is take the antiderivative of both sides. Because this is the antiderivative of 1 dv with respect to v. Well, what is that? It's v, right? Equals, well, what's the antiderivative? I'm sorry, I put the squiggle right through e to the x there. What's the antiderivative of e to the x with respect to x is e to the x plus some kind of constant, right? Okay. But for our purposes, we're not going to worry about the constant when we're doing integration by parts right now. So, e to the x. All right, so we got that. Oh, there's v again. Okay, we've got it. What else do I need? du, is that something I have? Is it something I can get? Yeah, and that's why I write that down here. Really, this is du over dx, right? Equals, and then, well, what is the derivative of x with respect to x? Is 1, and we're going to write it over. Remember, that really is, the dx is really on the bottom over here. We just move it up, right? Do I have everything that the formula is asking me for? Do I have it that I can replace it? I have u, I have v, and I have du. So of the four things that we have written down here, the one thing we're actually not going to use in the formula directly is dv, correct? It's one thing we're actually not going to replace. So here we go. Let's see how this works. All right, so that x needs to get replaced. What am I going to replace it with? Well, actually, no, let's not do it that way. We'll do it a different way. Let's just start writing. U is x times v. So we're basically taking those two times each other. So e to the x, right? Minus, and that's what this equals. Equals, right? You don't have to. No, if you understand that we're actually doing it now, that's fine. I'm just trying to follow the formula. Minus something, boy, I hope whatever we put in here we can actually do. I take v, which is e to the x, times du, which is, well, yeah, so now we're kind of going like this, right? 1 dx. And this is multiplied, right? Ooh, multiplication's bad in there, though, isn't it? But it's times 1. It's a constant multiple, so that's not so bad. Please do not forget that this is part of your answer. That's the part that's done. This over here is the part I'm going to try and finish. Is that something I can take the antiderivative of? It is. So this comes down and becomes part of your answer. Minus, well, what is the antiderivative of e to the x times 1 dx? It is e to the x. And now would be a really good time to put plus some constant. You see how we'd have lots of constants throughout this problem, and they would all just kind of add together to be different constants, so we're just going to write a constant. That is the antiderivative of that. How could we check that if we wanted to? Yeah. Oh, we just found the antiderivative. Yeah. Yeah. Well, out of curiosity, why don't we give that a whirl? Just as a nice review for derivatives. Let's give that a whirl. For derivatives, what do I got to do for this? Well, we don't have to, but so if this was our function, what would f prime of x be? If this was like, say, f of x, what would we have to do? Somebody said it, but you got to say it louder so everybody can hear you. Well, I'm just saying, what process would we use for this first term? Product rule. So you write down the first one, take the derivative of the second one, which is e to the x, plus you write down the second one, plus the derivative of the first one, which is minus, well, the derivative of this one is just, the derivative of a constant is nothing. Oh. Huh, we did get back to where we started. Yes, exactly. That means we did it right. Now, what did I say to not forget? Don't forget to try what first? Or at least look at it. Now that you've done a lot of substitution, you should probably be able to tell. I think substitution is going to help. Probably not. As of right now, do you know how to take the antiderivative of natural log? Notice I chose my words very carefully there. If you look at the sheet, you might, exactly. But I'm not going to have you do that until I make you actually take that antiderivative yourself. Okay, you're gonna find out why that works to be that answer. So for right now, I would not put natural log in the place that you'd have to integrate, which is where? Where should you probably not put it? dv, right? So we're probably going to stay away from that. So if we're going to try this one, substitution doesn't work. No matter what I make u, du's not going to be there. So here we go. These are the two things we start with. Now, can I pick and choose what I substitute when I'm doing integration by parts? Can I just pick and choose, leave some stuff in there, or no? No, you have to replace everything because it's a set formula. Well, I'm guessing natural log of x is going to go here then. Well, what's left? X squared dx. But well, when we integrate that, isn't that going to go up in power? Don't we kind of want them to go down in power? Wouldn't that be better? Well, I just told you not to put natural log over there, though. We're going to have to see how this all works out. So we know we're looking for u times v minus the integral of v du. That's a v. We know what u is. We know what v is. Not yet, but we can find it again. It's basically integrating both sides of this one here, right? If I integrate the left side, it's v. Integrate this side is x to the third over 3. Again, technically plus a constant, but. So we got v. Now we're back to this formula, minus the integral of v du. Well, I already got v, I need du. I don't know why I keep changing my colors on these, but here we go. Anybody remember the derivative of natural log of x? Yeah, x to the negative 1, otherwise known as 1 over x. Remember, that's the hard one to integrate, right? If you take it up a power, you're dividing by 0, then that's a problem. So do we have all the pieces we need? Now, the reason I always set them up the same is now, really, remember those little lines I made before? I have to do that and that, right? That's kind of how I remember it. There's your uv is this diagonal one. So let's take u times v. So natural log of x times v, which is x to the third over 3. I would caution you putting the x to the third on the end because it looks like it's part of natural log, right? So probably put the x to the third here over 3, right? That's the uv part. Everybody with me on that? I know this is the first day with integration by parts, so, but we're good so far? We're okay? Minus. Boy, we really hope there's an integral in here we can do. v du. Well, really it ends up being x to the third over 3 times 1 over x dx, right? So don't forget, this is part of your answer already. What's really in here then? X, yeah, because this x cancels with one of those. So x squared over 3, or really I could put the 1/3 out front if you want me to. Would you prefer the 1/3 was out front or out front? Okay. 1/3. So even though dv went to v as being something larger, that's kind of one way of looking at it, the x to the third over 3, it actually ended up being something I could integrate. Because what did we get rid of? From the beginning, what was in the beginning that was causing problems that we don't have now? Multiplication and natural log, right? Are all gone. So this one down here is done. X to the third natural log of x over 3 minus 1/3 times, well, x to the third over 3, right? If we integrate. And this is going to lead this way. So x to the third over 3 times the natural log of x. You can write it that way as well, just in case you see it written in answer keys that way, right? Minus x to the third over 9, right? Plus a constant. If the plus a constant wasn't there, it might not be a bad idea to factor out the x to the third over 3. But seeing there's probably going to be a constant involved as well, it doesn't really save you a lot unless the constant is 0. Are we good? I think all we got is one more. Well, what do you want to try? What's that? Oh, no dx. Very good. Now we can do it. Believe it or not, that was actually a mishap before, just a typo, but I left it in there to see if people were paying attention. Could have easily fixed it. Now what? Make u x, you think? Okay. Make dv then, well, pretty much everything else, right? Easy. So we got u. We need v. Uh-oh. Whoa, man. We need v. So in other words, I have to integrate e to the 4x dx. I have to integrate, right? How do you do that? With substitution. Or you get really good at these and you know what it's going to be. So inside integration by parts, you may have to do substitution. Oh, this is kind of like chain rule inside product rule and all that stuff. So u is 4x. Du is, now some people change their variable here because the u's and stuff over there, I just changed color. Apparently it worked for me. 4 dx. But I don't have a 4 there. I'm integrating this. Because I need to give v. So it's substitution inside integration by parts. Okay. So now when we rewrite it, it becomes 1/4 e to the u du, right? And what's the integral of e to the u? E to the u. So in other words, it's 1/4 times e to the u, and u is 4x. So this one is 1/4 e to the 4x. It's derivatives when you multiply by the exponent, the derivative of the exponent. Antiderivatives, you have to do substitution, and it's kind of, these you end up kind of dividing by it. Because I see some of you giving me a very strange look. Okay. So that was like a sidebar over here. I had to find v. Yes, the derivative of that is 4e to the 4x. And let's see, do we need anything else? Yes, du. This should be substantially easier than finding v. Because it's 1. No, you do not have to write the 1 if you want to write, but you do have to write the dx there. Because we have to make sure the dx ends up in the integral. Okay, let's find out. This is what we were suggested to do. I hope this works, because that was a lot of work. But then you do have the whole back side of that, so if this didn't work, we can just cross it off and try another one. Here we go. That times that. 1/4 x e to the 4x is the part that's already done, right? Because it is all multiplication, so I can kind of put it in whatever order I want, right? Minus. Now, really the moment of truth. It is these two. Well, we know we got a dx in there. It's your choice what you want to do with the 1/4. Want to put it out front? Okay. That is normally my choice as well, putting it out front. Well, if we only knew how to take the antiderivative of e to the 4x. Because we've already done it in this problem. That's tricky business. So this is part of the answer already. Here's a 1/4 that came from earlier. And then in here, I'm going to put what we know the antiderivative be. We just found it. It's right up here. We just did it to do that step, right? Of the exact same thing. So there's another 1/4 in here. Don't forget about that. That's just a really bad C at the end there. So really the only thing we could even clean up at this point, and I'll wait till I make sure everybody's got it down. The only thing to really mess with is that make it 1/16, right? Now, could you factor some stuff out here? Yeah. But you got to make that decision. That constant kind of makes a determinant on that, right? As to whether factoring something out is going to be helpful. So there it is. Now, in each of these cases, we could have taken the derivative, and it should have taken us back to where we started, correct? Now, the real question is, how many of you even bothered to look at to see if substitution was going to work? You did? Good. Because if that x had not have been there, we would have had it. Or if the exponent would have been, say, 4x squared, we would have been able to do it because the derivative would have been there, right? Or at least the variable part of the derivative. Okay? I hope you feel better at noticing when substitution is possible. Because I think you can agree it's way quicker. Okay? Any questions on integration by parts day 1?